Calculus BC 1.6 trig functions. How big is trig in calculus? It's the biggest. Probably close second would be exponential functions, logarithms, but trig pops up everywhere and it all ties together at the end. Anyway, so make sure you know it. What's a radian? Well, it's a replacement, and I can't say unit because it's technically unitless, for degrees. Because degrees is just, hey, let's divide the circle up into 360 units. Why? I don't know. The ancient Babylonians liked that, like the number 60, so we'll go with that. And 360 is a great number, don't get me wrong, but radians make life simple. So you take your degrees, you multiply by pi over 180. So that 360 degrees equals 2 pi radians. And the radians is a very strange unit. Suddenly just vanishes, it's unitless. I won't get into it. Find the length of an arc subtended on a circle of radius 3 by a central angle of 2 pi over 3. So here's, I doubt that's to scale. I'd have to think about it a little bit harder, and that's painful. So the radius is 3, and this is 2 pi over 3. Well, arc is just r times theta if theta is given in radians. So 3 times 2 pi over 3 equals 2 pi. That's the actual length of this. If I was making a pizza and I just had to make that part of a crust, that's exactly how long it would be, roughly 6.28 inches, meters, millimeters, whatever you get. What's this thing? This is a unit circle. I hope you remember what it was. I'm actually going to pause this and fill it out. So, just filled it out. Took me more than 3 minutes, I'm not going to lie. But hopefully you can pause this and copy it down, or hopefully you know it from memory. I didn't quite finish. The quadrants are 1, 2, 3, and 4, always in Roman numerals. And cosine goes with x, sine goes with y. There will be many, many calculus problems throughout the year where you're expected to know the sine of 5 pi over 6 without looking it up, writing the unit circle. You have to just be able to say, oh, that's 1/2. Done. So be prepared. One of the things I see all the time on ACT problems and the whole works is this standard angle. Radius is r and the angle is theta, the vertical is y. And then we go with the whole sine, cosine, tangent stuff. Sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta equals opposite over hypotenuse. Cosecant of theta equals r over y. Secant of theta equals r over x. Cotangent of theta equals x over y. So those are the 6 basic trig functions, and that's how they're defined. You should remember them all. I'm going to do quick and dirty graphs of sine. Which is that. And while I'm at it, let's do cosecant, which is just 1 over sine, which has asymptotes. And we can do cosine. And while we're at it, secant. And last but not least, we'll do tangent. Tangent I can't remember, so I have to stop and think. And I say tangent is sine over cosine, and sine is 0 at 0 degrees, so tangent's going to do this. Hit an asymptote, and do it again. Notice how I am not putting in all the details. Again, I expect you to know most of this. If not, you better go back and review. I'll do some of this as we go along, but a lot of it, again, you're expected to know. Cotangent has an asymptote here and an asymptote here. So I will just do the one cotangent that goes like that and it repeats. Most important thing to remember about these is the periods, domains, ranges. So what's the period? Well, period is how long on the x-axis until it repeats. So sine, cosine, cosecant, and secant. Period is 2 pi. For tangent and cotangent, period is pi. Remember those, that's very important to remember. So here's a problem that we're going to put into standard position. This is a little mnemonic to remember where things are positive. All are positive, sine is positive, tangent is positive, cosine is positive. And sine means sine and cosecant because they're inverse functions. So if tangent's less than 0, we're either in the top quadrant, top left, second quadrant, or the fourth quadrant. And it says sine is negative, so we are down in the fourth quadrant. So I zoom in on that, draw it up to my x-axis, throw my theta in, and sine is negative 3 over 5, therefore cosine is 4, the adjacent side is 4. So sine is negative 3/5. Therefore cosecant, notice I'm lazy, I don't write the theta in. Yes, you need to do that on a test, but these are just notes. So cosine is 4/5. Secant is 5/4. Tangent is negative 3/4. Cotangent is negative 4/3. That's all the trig values. Old stuff for those of you from pre-calculus. How about graphing something more or less from scratch? Let's go with the period. It's cosine. So it's 2 pi over this 2 value in front of the x. So I'm going to go and label that later because when I graph it, it might all get messy. Amplitude is 3. Vertical shift is 1. Horizontal shift is pi over 2. And I know different teachers do it different ways. I don't like to be ambiguous, so to the right. Domain and range, I'll get to the range in a second. The domain is everything. It just goes on forever and ever. And the range, it's going to start at 1, go up 3, so it's up as high as 4, and that's inclusive. And it starts at 1, goes down 3, so it goes down as low as negative 2, also inclusive. Let's see if I got that right. So 1, 2, 3, 4 tick marks. We'll put a dotted line at the vertical shift. We'll go up 3, 1, 2, 3. Just remember, I need to leave some space there for my labels. And down 3, 1, 2, 3. Looks like my range is good. Should start at the top and go down. But we got to shift, and so now I need to label. These are that's pi over 2, so it's 2 tick marks to the right. So I'm going to give it some different color. This will move 2 tick marks. This will move 2 tick marks. So here's my final graph. And what I typically do first, and I deliberately left it off because I didn't want to get in the way, go 1, 2, 3, 4. That's my period, which is in this case is pi. And this is pi over 2. That makes this pi over 4. 1 pi over 4, 2 pi over 4. Again, things get in the way. 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4, but of course we write that as 3 pi over 2. And 1, 2, 3, 4, -1, -2. And that's graphing. And is that it? Nope. Hard stuff. That's funny. What's it mean, cosine negative first? And I write it as where does cosine equal, I will put my angle in, -0.5. That's how I read it. There's a couple spots on the unit circle, but since this is written like this, that means arc cosine. That means we can only use from 0 to pi. I gotta think if that's right. Yeah, that's right. So negative is going to be in the second quadrant. It's cosine. So if I'm not mistaken, that would be at 2 pi over 3. Hopefully I didn't screw that up. So what if I wrote it this way? Well, then you could find anywhere, because it's not an arc cosine problem. It's not an arc cosine of negative first problem. Not arc cosine, which is defined. It's anywhere. So you could go on and say 2 pi over 3, or -4 pi over 3, or 4 pi over 3, or -2 pi over 3. You've got lots and lots of options. So that's the difference between those two questions. So we call that an inverse trig function. For sine to the negative first, we define it as from negative pi over 2. Pretty sure it's inclusive, but I got to double check. This is the range, of course. I guess I should do domain first. Domain, since it's an inverse function, is from -1 to 1 inclusive. And the range is negative pi over 2 to pi over 2 inclusive. Cosine, like I defined it above, domain is same, -1 to 1, and the range I think I just defined from 0 to pi. I did. Inclusive. Tangent to the negative first. Domain is, yeah, I thought it was all reals. -infinity to infinity. And the range is hard to remember. Yeah, negative pi over 2. It's the same as sine. That's how I remember it. Cotangent has same as cosine. I mean the same range as cosine. So its domain is from -infinity to infinity, and its range is from 0 to pi. For secant, domain is absolute value of x greater than or equal to 1. And I'm actually going to change that. You should get used to seeing that. It means negative infinity to 1, and to negative 1, and from 1 to infinity. And its range is 0 to pi, as long as you don't have pi over 2 in there. Then for cosecant, domain is the same. And range is from negative pi over 2 to pi over 2 without 0. Significant hassle. So, yes, you can graph them another time. If I were you, I'd go look up your notes and graph them yourself. That's it. And that's a lot. Happy mathing.